Hi, welcome back to, I think we're on part 5 of this series on creating a virtual console. We're using a lot of AI to do so. I realised, if you've watched episode 4, I realised after the fact that I hadn't kind of zoomed the browser view, so apologies if that was a little small. I have remembered this time, and you can hopefully see it is zoomed. Yes, apologies for that. Recording myself coding and thinking is fairly new to me, and I sit on, I use Teams a lot at work. Horrible product, Teams, but I sit on Teams a lot, and we never have any problem with screen size. But obviously, people watch YouTube on all sorts of different form factors, and I just forgot to zoom my browser. And sorry about that. But if you recall, we left that episode with a sort of embryonic dev kit. And we were looking at a screen that was a little bit like this. We could assemble some code, load it, and it would load into memory, and we could start stepping through it. We had the AI generate parts of the React app for us, and after that episode, I mentioned at one point having a React guidelines, because some React wasn't quite how I might want it, and also for that episode, I did some review of code it had generated, and it wasn't very componentized. There was a lot of really heavy Tailwind use, and while I haven't fixed all of that, that's not really the purpose of what we're doing. But it's I want to get something really interesting happening in the console, and then we can start to do more things with the code. But I wanted to address at least some of it. So I have created a React guidelines file. I took the same approach to this that I did with the TypeScript guide. I started with things that were important to me. I made a typo in one of the things that was important to me, which I will now fix. And I then asked Claude to fill the rest in with some things which were common in TypeScript guide, just give me a sensible React guide. And then I added some more bits and pieces on based on that, and a little specific bit about virtual console integration. And then what I did is I took that and I asked it to apply that to some of our files. I gave it a bit of a pointer as to what to do when I did that. So we've now got this components folder with a hex address input in it. That was kind of code that was embedded directly in our memory viewer. Didn't really feel good. So that got extracted to a component. A panel got extracted just to some basic layout, and then all that kind of got applied across the application files. So the memory viewer is a bit more focused on the memory view now. Again and again, register view. I think it uses a panel now. So I just did some sort of kind of light refactoring to push these into the right space. The constants got renamed based on our TypeScript guide. So I basically nudged this into slightly better shape following that last episode. In this episode, we're going to try and do two things, which hopefully will fit inside an hour. I'm not sure I have a stamina for another 2-hour episode, and I doubt anybody watching this does. So I'll try and get it into 1 hour. And those two things are, we go back to the browser, we're going to get Monaco to give us some help, some proper syntax highlighting. Everything looks wrong in here. I think it's probably based on JavaScript or something. Not helpful. So we'll get that to use our assembly syntax. And I can't quite remember the construct that you do with Monaco, so we will ask the AI about that to help us with that. I'm pretty sure we can load it when we initialize Monaco, but I can't quite remember what it's called. So we're going to do a bit of back and forth to figure that out. Then the next thing we're going to do is we're going to get the CPU running. So at the moment it can step, but it can't kind of run. And the reason I want to do those two things is in the next episode, I'm really hoping we can get something rendering on the screen. And that will require the CPU to run. I don't want to step it through, doing 10,000 operations to draw something, and I think it will help us understand more complex assembly if we've got some syntax highlighting in place. So we're going to do those two things this episode, and I guess we will dive into the Monaco thing, because once we've done that, the CPU will lead nicely into, I hope, the rendering. Great. Apologies if I seem a little bit tired as I record this. I had a very long hike with my dog this morning, which was nice. It was sunny out. It is no longer sunny out, so we timed that right. But yeah, so a little bit windswept, cold swept, as it were. In any case, let's get going. You don't need to know about my non-virtual console activities. I'm sure they're not very interesting. This is all kind of left how I left it. This episode, I guess, will go out a few days after the previous episode, but for me, it's the next day. Yeah, so it's kind of how we left it. I'm going to shut Claude down, and I'm going to go and look into our editor, refresh myself what's in here. Editor container, where do we put our Monaco? It's in here, isn't it? There's our editor. Okay, that's a Monaco editor. Okay, so we're going to write a little spec for this. And again, I'm going to do that in VS Code rather than WebStorm. I tend to use VS Code as like a classic editor and WebStorm as a classic IDE. For me, when VS Code starts to go wrong is when it tries to be an IDE and it doesn't quite gel for me. I know people love it, which is great, whatever works. In any case, we're going to ask Claude to extend some syntax highlighting out. Put our syntax highlighting. So I'm going to say begin by reading these documents. So we're going to give it. What I'll probably do as well is create a prompt template that kind of has a lot of this stuff in, because I'm repeating myself quite a bit. So normally, once I've got some specs and things in place, I'll have a little prompt template that I can just start Claude up with. So we might do that this episode, but for now, let's just write this out. We want it to read. We're going to be in our devkit folder. So what do I call it? React-guidelines.md. CPU specification, which is going to be in devkit. Go back to the root, I think. .spec / hardware / cpu.md. Let's see if I got that right. Nope. Because of that. Cool, so that's the right path, just a little typo. Okay, assembler specification. Tools / assembler.md. Our text editor. That's going to ./source / editor / application / editor container .tsx. I want you to update the editor, the Monaco editor. So it starts up. So when it starts up, we configure syntax highlighting to support our CPU instruction set and our, so put around our assembler syntax and CPU specification. Might be all we need because it's fairly. I think from what I remember of Monaco, it's fairly constrained. If you need to, if the code to create the language specification, I think I might call language specifications or something for Monaco, is more than let's just tell it to do it, because it's going to be all in 10 lines, isn't it? Create code that provides in the file ./source/application/ assembler .ts. Okay, so I'm going to pop that into Claude and let us see what happens. We're off. Once again, I'm thinking, how long have I been rambling? Yes, you can read things. How long have I been rambling? I must set a timer. I've not done a conference presentation for a while, but I would normally have my timer going. I really need to start doing that. So I have some idea how long I've been rambling. Okay. I got the spec wrong. I got the path wrong. Oh, no, I didn't. Specs. Chopped it, and hopefully that'll let it continue. Yeah, so hopefully this shouldn't be too, I don't think it's going to be too difficult for it. It's very simple syntax. I'm not expecting it to have too many issues with this. I just can't quite remember the syntax. I can't remember what Monaco calls it. I guess we'll find out when it's done. Oh, yes, you can create that file. And just make all the edits you like. I've created a commit checkpoint before we began, as per usual, so we can always roll back if we need to. I'm not sure if we've done that yet. I think we did once, maybe roll some stuff back. Okay, it looks like it's making sensible changes. Okay. Okay, that's pretty quick. I thought it might be. Let's have a look at what it's created. So this is our okay. So there shouldn't be much in here. It's just going to register the. I guess it's going to register the assembly language. Okay, yeah. So this is going to come from here. Okay, surrounding pairs. This is brackets. Okay, this is for the comments. Brackets, auto closing pairs, surrounding pairs. There's our opcodes, branch instructions, operators. Okay, it all looks pretty good to me. Okay, a tokenizer. Interesting. All regex based. Okay, so it's created a tokenizer, can extract the tokens from the source. Okay. Interesting. Okay, let's see what's looking in our browser, because it's probably, I might not actually have the build running actually. Oh, I have. Okay, it's not showing any errors. If I put some nonsense in, it's not doing anything. Okay, so that's not quite right, is it? What if I do something like? No, so it's just removed all syntax highlighting. So let's have a look at register language. Okay, let's ask Claude. it looks like what goes in. I don't get errors. Just seems to be treated as if it's plain text. Okay, let's see what Claude makes of it, because I don't particularly want to have to fix this by hand, but if needs be, I guess we will crack out old-fashioned Google, but I suspect we won't. Okay, I've come across before mount in my, I mentioned my angular travails with Monaco. I've come across before mount before. Fortunately, that work is on my work PC, which I on my work Mac, which I don't particularly want to go and open on a Sunday. It's a Sunday for me. I guess I could have gone and referenced what I did with Monaco over there, but some time ago I did that work. Okay, let's see what happened now. Ah, there we go, look. We've got the syntax highlighting, and I better put some nonsense in. Okay, it doesn't look like it's showing errors. Okay, that's pretty close. That's pretty good, but we're not seeing any errors. It's pretty good. Any errors? Okay, we now see. Okay, let's be a bit more specific. Well, I find you can be quite chatty quite often with this stuff. That's better. We now see syntax highlights, but we don't see errors on invalid syntax. To be fair, I didn't ask it to do that. I didn't ask it to show errors on invalid syntax. It's interesting. The other thing we'll do, we won't do this today, but the other thing we'll do is we'll get our errors from assembly. When we get assembly errors, we'll get those to show as well, as if you were doing like a compile. We'll have a little slider come up at the bottom. It's a bit bigger, it's quite small still. Hopefully that's a bit better for people. Okay, I've never used Monaco's markers API, so that's interesting. Literally never heard of it, literally never used it. So it's actually going to use the assembler to validate the code as we go. That's really interesting. Okay. Well, maybe we're getting this thing for free. I guess we're not. I'm not. We'd have to put a little thing popping up to show the errors, but we're kind of getting errors for free. So there's a future episode we don't need to do. Interesting. I'm generally curious as to how it has worked with markers. Let's just look at the diffs. Git show diffs near the top, isn't it? On mount, on change. Okay, I'm not sure where we've registered that then. So I know nothing about this. That's one of those things I don't even really know where to look. Ah, here we go. So validate the code. Okay, so I use the diff because I've so not used this part of Monaco, but I didn't even know where to look. And here, this is validate code. Okay, interesting. Passes the program through. That doesn't look right. It's passing up on initial mount. Validate the initial program. Okay, then we validate the program as it goes. Okay, so let's go to the implementation of that. That's probably it's not used. Yeah, okay. Interesting. So it's reading out the error from our assembler errors, which our assembler generates, and it's applying it in the console. So it looks pretty sane. Let's see what happens. I might have to refresh it. It works. How cool. Wow. That's really cool. That's really cool. That will help us write more complex assembly. It's just basically using our assembler to generate the errors and then map them onto the source code as we type. That's really cool. Great. Sometimes this stuff leaves me stunned. What I'm going to do here though is in here, if we don't need that error. If you assemble first an exception, I'm actually in a console.error. It shouldn't throw an exception for a normal error. So if we do get one of those, we'll pop it to the console so we know about it, and that gets rid of that warning. Let's just look for. We know we've got that thing about bracket comma. Okay, we can take this out, can't we? So let's see if that's true. I think it is true. Again, regex though. Whoa, shudder. Yeah, it's fine. We can take that out. Commas are absolutely fine. Interesting, that doesn't generate an error from the assembler. That's curious. Okay, we might need to look at that. I don't think it matters for now, but I suspect what's happening is it's just picking 2 and discarding the rest, but we probably want to make it give us an error, but we'll come back to that a little bit later, because I want us to crack on to some stuff that's more visual and try and help this project come a bit more to life in text editors. Okay, so great, we've got some syntax highlighting. Now let's quit this. I should have my... no, that's me doing something else last night with local models, which we will come to. That's foreshadowing. I think I said I've got quite slow broadband, so last night I set some things downloading. Okay, yes, let's just redundant -a, but never mind. Monaco syntax highlighting. Okay, so I would say that's another pretty decent step forward. That all makes sense to me. I have a fair degree of confidence in this at the moment because it's built a bunch of interlocking things around this spec. So I think if there are any issues, they're going to be spec errors rather than code errors at this point. I could be wrong, but as we work through this, we will probably take some of the assembly we generate for more complex things and drop them into tests. And I'm sure at some point we're going to find something really nuanced that is, I suspect, wrong in the spec rather than the code, I say at this point, but we will probably find something as we go, which is fine. Okay, and what it's done here is fairly, it aligns with the spec I gave it for TypeScript. It looks fine, and yeah, great. So I think we're in a pretty good place. At the moment, I think I'll leave editor as is with this. Editor container with the editor in it. We call it editor container because of the clash of the name of a component, if you recall. I'm not quite happy about that yet, but I really don't want to be aliasing editor, Monaco editor. That just seems, I don't like to alias call things like Monaco editor before, so I'm going to leave that as is for now. And yeah, let's move on. Great, so slightly more challenging. I have some ideas how to approach this. I think they might work, and I want to take a specific route to it, which is I'm not an expert on emulators. I've looked in emulator code from time to time. Most emulators do things on the main thread, particularly for old systems, because there's plenty of time in the render loop and we'll come to rendering, but if you use a browser, you've got the render animation frame request, which you can use, and it'll trigger every refresh. On this monitor I'm using here, it was 60 frames per second. On my laptop monitor, it does 120. I'm working on a MacBook Pro. My monitors are, I guess, quite old at this point, probably 5 years old. They're great quality, 4K monitors, but they are from when getting a sort of 60 FPS, I think they're OLED. Anyway, they're great colour and really bright. But at the time, getting something above 60 FPS and of similar quality was astronomical sums of money. And because I spend most of my time coding, 60 FPS is completely fine. So I got these monitors. But that's the difference. But it is actually quite useful, because when you do graphic stuff, it does highlight the difference between running on a faster panel and this panel, and how that impacts your code and a browser. So there is a method called request animation frame that runs every n seconds, and you can detect in there how much time has elapsed, and track the frame time deltas, which if things are going well, because your code performance is going to be 1000 milliseconds divided by 60 frames per second, and it will stay pretty solid on that. And that's often in there is often where people will run the CPUs in the emulators, and how many cycles can I fit for the processor speed in the amount of time that's allotted, and off you go. It will do that in that, and then you do your render logic, and you can all that sort of stuff, and then render the frame, move on. And on modern browsers, modern kit, you've got plenty of time to emulate old systems in that window of time, and it's simple. It works. Great. However, I want to use a web worker. I want the CPU to be running separate to the video system, and continuously as it would on a real piece of hardware. And a bit more foreshadowing there, perhaps. I'm doing a lot of foreshadowing in this episode. However, I'd like it to be separated and constantly running. So I want to build the CPU in a web worker. And I guess if you've done any work with web workers, I've done quite a bit of work with web workers. I've done a fair amount of browser-side sort of multi-threading data analysis, parallel data analysis, while users are doing things based on what they're seeing in a browser. I've done quite a lot of work in the web worker space. And one of the things you have to do with them, similar if you've written like Chrome extensions, it's the same kind of patterns. You've got something running in the background, you've got something running in the browser's UI space, and you have to talk between them. And you do it through message passing. So in our web worker, we would need to pass the state into it through a message, and pass the state back out to it through a message, which is fine for 8 registers. It's not okay for 64K of RAM, but we might want access to pretty frequently, for example, to render the system. However, there is a construct called a shared array buffer, and that you can use to essentially share one of our array types, one of these fixed type arrays, between workers, between processors, so between the UI thread in the browser and the web worker, and they'll be looking at the same memory. There's no marshalling backwards and forwards, no serializing costs, so we can use that. Interestingly, it got disabled a few years ago. It's now re-enabled. When all that Spectre stuff came out, if you remember the CPU vulnerabilities that came out, which was a right mess, and it got people very angry because their PCs would have to slow down because that was the way to fix it. The patch required things to be, required more work to be done in the CPU's microcode. I could get some of the CPU terminology wrong, but Spectre meant that the browsers had to disable that construct because it allowed some vulnerabilities, some exploits to take place, which I don't know the details of. They're probably mind-blowingly complicated and clever, but it got disabled for a time. It has now been re-enabled, and you need to support put some cross-header flags on, cross-origin flags on, cross-origin headers on, to support to allow it to run. But that's now re-enabled, so we can use that to share our memory between the CPU. It can be pointing at the memory bus, and our debug tools can be pointing at the memory bus, and our renderer can be pointing at the memory bus. And why might the renderer be pointing at the memory bus is a question you might ask. That's because if I look to the memory layout section we've got, in the 8-bit systems, if you had linear video memory, for example, BBC Micro, it would actually come out of your 64K of RAM, but the 8-bit processor could address. So something like Elite, which ran on a 32K BBC, I think they did some clever tricks with the hardware to save memory, but I think 8K of memory was actually video memory, and then it had like 22K left to actually run in. There's a little OS space. I had to stay. My dog is barking, if you can hear this. So it's probably walking past the front. Yeah, she's not tired from the hike. I'm absolutely exhausted. She's fine. Yes, so it came out of memory, and in here, I believe I documented video memory is in one of our paging banks. Let's go down. Video memory. Is it here? Frame buffer layout. Here we go. So our frame buffer is in the top part of the memory. So it will run up to the end of memory, depending on how much memory is needed. We've got 4 modes. But this means that our video system also needs to be accessed from memory. And in the layout I'm talking about, and I might, I'll try and drop a diagram of this to overlay in here while instead of looking at this as part of this narrative. I will drop a diagram in. As part of these 4, as part of this system I'm going to set up where the CPU is running, CPU running in a web worker, rendering will run in the UI thread in the request animation frame I talked about, and they will both need to access the frame buffer for when video operations are taking place, because to draw into the memory, to draw on the screen, we're basically manipulating bytes in the memory bus. So we both need access to that memory. And breathe. Hopefully that makes sense to people. Hopefully it makes sense as we put it into code. I say I've not. Have I used shared array buffer? Can't remember. Probably, but not for a while. But I know of its existence. So we have got in here. What have we got? We're probably going to write a spec for this, I think, and see how far we can get with Claude on its own. So at the moment we've got console integration, virtual console, and it's just running the console in here. We don't want to do this anymore. We need the console to be running, or at least the CPU part of the console to be running somewhere else, and we'll need to change a few bits and pieces around it. So that's how I go writing the spec. Get my forks in order. So we ask it to begin by reading. Doesn't need that this time. Doesn't need that this time. Doesn't need that this time. Point it at the React integration. I think it's a TSX, isn't it? And we've got, I think we're doing with paging, we've got our toolbar, our debug view, and debug toolbar. So it's going to be a debug toolbar that's going to be the thing we need to update. Okay. Update memory snapshot. Yes, let's move this update memory snapshot. I think that we will need to look at, which is in the store. Okay, so I'm just conceptualizing in my head how it is going to work, so I can express it accurately to the LLM, and I might just have to start writing and see what comes out of my head. Okay. So we're pointing over devkit store as well. Okay. Oops. I think the other thing I did in the refactor actually, which I mentioned, is I pulled some duplicated code which updates the virtual console snapshot into this little utilities file alongside the store. So I'm also going to point it. I think it doesn't really care about spelling mistakes. Not to that level anyway. Okay. We want to run our CPU within our virtual console inside a web worker. CPU should run at 3 megahertz. Both the CPU and with the CPU in the web worker and the render loop and the browser UI need access to the memory. We should use a shared array buffer to performant access to the memory from both threads. If necessary, we should update the. I think it's over. This is a browser thing, not a node thing. So I don't want to really put it in the CPU. A good place to manage the shared array buffer would be in the use virtual console construct. We could have that we should refactor this. We should refactor use virtual console so that it actually returns a type that self access to the shared array buffer. So we might have to do this, but we'll see where we get to. I'm sort of mapping the code out in my head, and I'm just wondering if it's going to be not possible to do from the outside. I think we can do it from the outside. I think we'll just create it and pop it into here. Let's see. Access to a shared array buffer. Methods to step, pause, and run the CPU. And then the web worker as messages. So you normally sort of post messages back and forwards between the threads in the browser, and that's fine because they pause and it'll pause. Accordingly. Okay, and then I want to say with this one, please ask, please, any questions you might have before undertaking the implementation. I dread to think what questions it's going to have. They might require more LLM use for me to be able to answer them. Let us see. Okay, so we basically try to give some guidance as to what we want. You know, we've kind of architected it roughly in our head. And again, it's one of those things where I don't really feel it needs a super precise spec. I think it's okay to have it in this sort of form, and I think we'll get what we want by this level of spec. I could be eating my hat in 2 minutes' time. We'll find out. But again, I think the trick to, and I'm still learning this, right? I'm still learning this myself. I am not the oracle of using an AI assistant, and I think, well, to be honest, if anybody tells you they are an end-to-end, know everything expert on it, they are probably lying, because it moves so fast. This space is moving so fast that you're an expert for one day and you're not. But as you get more experience, you start to understand and get a feel as to where you need the more comprehensive specs and the less comprehensive specs. I think I've said that before, and this is one of those cases where I suspect we've got enough weight in the assets we've got that it can process this and do what we're asking. There's also going to be plenty of patterns in its training data of similar things, which is the other angle on this. It's not going to come at this completely cold, as it were. It will have been trained on it's been trained on code, and it will have seen some similar things. And we'll see where we get to. Just going to see how long I have been going. 40 minutes. We've got 20 minutes. Rush. Come on, Claude. Okay, it might be a little bit longer now, but I hope not. I don't think this is going to be too big a step for it. I can sort of see the web worker code in my head. I think it's going to have some sort of okay, it's got some questions in it, but I think it's going to have some sort of wait until it's going to use the performance .now or performance timer.now, whatever it's called, to get a microsecond accurate timer. They're not that accurate, but they're accurate enough for this. And it's probably going to say when you get to more than 0.n, run some cycles. I suspect that's what it's going to do. Let me see. What is it asking? Okay, asking quite a few questions actually. So it's asking. So interesting. It's asking the questions that I was asking, which is how should we do the memory bus? I think we want option B. That I think we pass the memory bus, the U8 array. Yeah. So. Option B. Okay, so actually I think what we'll do is we'll just copy these out. We'll do our normal, what we've done before, which is where we go and answer its questions. Okay, do that in a new window, make that markdown. Why it always thinks this is YAML, I'm not quite sure. But it's understood what we're trying to do, which is great. Top. Good question. So that thing like thought made sense. It doesn't make sense when you think about putting it into a web worker because you can't access the CPU instance of a web worker, so we can remove it. Yes, I think. I think we should make it read-only for now. We can always change it later. Yeah, the UI doesn't need to write to. The UI might need to write to memory for interrupts and for things like some of our hardware things. So because basically we're going to have some like we will have memory space. So we have peripherals that are mapped to memory space, for example, a controller. So that will come from the UI thread, from the browser thread. So okay, so we're going to be, the console's going to be, think it's running on an old TV. So, 60 hertz. I mean, it was 50 hertz in the UK on PAL. I think it was 60 hertz in the US. We're just 60 hertz, much nicer frame rate. That was always a point of contention. If you're watching this in the US, our 50 hertz PAL consoles, the ports were often poor, as they, so the game just slowed down sometimes, and can't quite remember. It was always a point of contention. Worker lifecycle, should the hook create and manage work internally? Should we give a passive parameter? I don't really mind. I think it should create it internally. Create and manage it internally. On mount. It will have things like controllers. They are mapped to bytes in the memory space. Okay, we went through that. Okay. Option B. Okay, so don't need to save it, I want to copy it. What am I doing? Wrong key, for the wrong key. Right, definitely copied it. Okay, let's feed back to Claude. I mean, the good news is it generated a bunch of very sensible questions based on what I asked it to do, and it reading the code. That in and of itself, I think, is pretty impressive. If 5 years ago someone had said we'd be doing this, I might not have believed them. It's pretty impressive, I think. Okay, so it's asking me another question. Execution strategy. Okay, so look, main thread create shared array buffer, actually memory bus for access. Okay, see shared array. Yeah, create memory bus for CPU. Yeah. Yeah, that looks right. 3 megahertz, 60 Hz. Yeah, that's fine. I might. So in my head, I think it's using set timeout to kind of pause itself, but I think with WebWork it can just freewheel. Like you can see the code, it's kind of dreamt up where it's cycle runner, it's going, set timeout, run it again. But I think it can just freewheel. The set timeout is not always that. It says precise batched execution. I'm not sure set timeout is always that precise. So when I ask it, can the web worker not just freewheel? Otherwise, it looks good. I guess, if you're running on battery or something, you might, I guess burn battery on a laptop. You're right. I love its cheery. Absolutely, we could do it this way. It's a better way of doing it. I love its cheery, nature. Okay, it's adding a constructor so that we can pass memory into it. Okay, fine. Yeah. Okay, cool. Yes, you can do that. Yeah, I always love its cheery responses. That's a great idea. Why didn't I think of that 30 seconds ago? Really makes me, every time it makes me chuckle. Every time, without fail. I didn't actually say where to create the web worker. I hope it will create it in console integration. We'll see. It might just create it in the existing TypeScript file for Virtual Console. We'll see. So it has created a new. Great, it's created a new file. Yeah, that's fine. I'm going to let it run its, spin on. I'll probably keep returning to this topic, while we go through a series with the AI. But this, to me, is how the developer's role is changing. I'm not doing all the typing and the boring work. I'm kind of guiding it. I've got a sense of architecture. I've got a sense of appropriate technologies. I've got a clear view of what I want out at the end of it, including beyond this series, hence the foreshadowing. I've kind of got some views as to how this will go, and I use all that to essentially have a web worker be a small team, as it were, running the web worker, so Claude, having the AI essentially take my directions and turn that into typing, and almost like a sort of junior or, dare I say, mid-level developer. So it's really powerful. I find it really liberating. And I guess the big question is going to be, does a productivity boost like this? Because there's no doubt it's a productivity boost. I mean, there's plenty of people, AI is useless, blah, blah, blah. And there's plenty of people, AI is the best thing ever. It does all these wonderful, magical things. And neither of those extremes are right. It's a really useful tool. But it's definitely a massive multiplier for developer productivity, for sure. I think even the stuff we've done so far in this series, I'm not sure how you could argue this is not a useful productivity boost. And we're not generating something random. This isn't. We get a really tight spec for a CPU. We're not generating something that is a random output, create something that's vaguely like this. We're nudging it through creating something that's really specific. And okay, some bits are looser than the others. I've been a bit loose on the UI, not bothered about the UI yet, but it's not just it has boosted our productivity massively, which again is why I wanted to create this series, to help people understand that and help other developers hopefully get a feel as to how I use it, and perhaps that's helpful. Also, we get to create something really cool, which is, the other reason for doing this. In any case, okay, it thinks it's done. It's built as well. It's compiled it. I saw it compile it. Let's have a look. Let's look at the CPU worker to begin with. So this is going to be the sort of meat of it. Great. It doesn't start running because it's starting up, not running. Which is, I was just going to check: is it started running or not? Okay, that's a sneak preview snapshot. Okay, so that's the things that the UI want to access to, and that's okay. We can ask it for those things. That's absolutely fine. I guess we could have asked it for a memory snapshot too if we were just displaying it in the debugger. But we'll say we've got two different threads that need to access the memory. Okay, so cycles per millisecond. Based on our target frequency, yeah, okay, divided by 1000, fine. Okay. execution loop. Okay, so it gets a timer, number of cycles elapsed. Okay, looks pretty sensible to me. It's just going to run, it's going to step on the CPU n times for a number of cycles that elapsed in this period of time, measured by our performance.now. It's to set timeout to yield. Okay. I'm not sure if that's needed or not. Maybe it is. Yeah, I guess it's using that. I guess it needs to. I've not had something run quite like this and never yield, but I guess it needs to yield so that when we ask it to stop, it can stop. It can get that. It can handle that message, because this in and of itself is single threaded. Yeah, so that's why it's doing that. Interesting. I'm not sure what impact that will have on the runtime. I mean, it will smooth out because this thing is going to, account for this thing. So it's going to smooth out, but interesting. Okay, message handler, initialize it with shared memory. Okay, run, turn it to running, set the timestamps, call the execution loop, mark it as running, paused, step. Okay, so that's where we'll go over. We're just going to call it once rather than run the execution loop, get the snapshot, reset the CPU. Okay, set the program counter. Okay, I mean that all looks sensible stuff to me, kind of stuff I expected to see in there. Virtual console.tsx. Okay, it's declared interface. The shared memory. Okay, great. Memory bus. Okay, run, pause, step, reset, set to get snapshot. Fine. It's going to just initialize this. Not that interesting, really, compared to the CPU worker. Snapshot resolve as ref. Okay, right, it's created a reference up here. Okay. What's it doing here? Resolve pending snapshots. If you've asked it for a snapshot, okay, this is stop us asking for too many asking for snapshots before and everyone's come back. Okay. Initialize work with share memory, post the messages, get a snapshot. Okay, we configure it. Fine. That's going to be the hot module warning, or a fast refresh rather. Don't care about that. Okay, so it looks pretty good to me. What's happened in the store? Okay, this has changed a bit. Has this changed? Has this changed? It looks simpler. Can't quite remember what it was like before, so a quick look. Yeah, okay, because previously it was doing this against the CPU, now we're doing it against the against messages. Okay, fine. Let's close that down. Close that down. Doodle toolbar. Has it added? Did I ask it to add buttons? I didn't ask it to add buttons. So it's just going to update this so that our step still works. So the first step, let's see if our step still works. Okay, so it's done some stuff. I'm going to leave that context there. Set this running again, just in case. Refresh my browser. Interesting. Okay, nothing is working. What is going wrong? Shared array buffer is not defined. Interesting. Okay, let's go into let's go virtual console.tsx. Okay, I'm not sure why we're getting that error. I wonder if we need to do some work on the cross origin options I mentioned earlier to enable it to see this. Let's get using Edge. Okay, yeah, so it needs to add the headers. Okay, so it's what I was talking about earlier. Even running on local host, we have to add those headers to re-enable it. Okay, great. And it's now running in the background, look, because we made these changes. I'm so happy it was that, because if it wasn't that, I had no idea at all. I would have been totally out of ideas. So let's finish its bit. Okay, so that was good. Yeah, we know we'll need to do that. And when I put this online, I'll probably put it online using Netlify. And we just need to create that headers file. Let's have it create the headers file. So let's have it create a headers file, and before we forget, because otherwise what will probably happen is when I put this online, I'll forget about this and spend a morning wondering why nothing's displaying. Inevitably that will happen. While it's doing that, we should be able to test the browser out. Let's have a look. So, okay. Now hopefully when we click assemble, it will load things over here still. Okay, looks good. Can we step? We can step. Okay, so our system still runs. I'm going to ask it to put as the last thing in this episode, I'm going to commit this in a second when it's completed the headers. We're going to put the run and pause buttons on. And then what I'm going to do is have it run. Just press run, and we should see when I then pause it, it just have filled this memory space, and I think it'll have stopped on the NOP depending on the program. No, because it won't stop on the NOP because the CPU is freewheeling. The stop on a NOP is an artifact we put in here for. I'm talking complete nonsense. If you recall, when we did the console version, we needed a way to mark when it ended, so we could go back to the menu, and we chose to use a NOP instruction, which is why these things have got NOP at the bottom, which is 00. But actually, we didn't do that in this. So I think if we run, so it's filled all 10 things. What we'll find is when it gets to the end of a program, one more maybe, yeah, okay, it will just keep running across the NOP. So that's jumped to the end now. NOP, 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 NOP. So we might see a crash because our program counter might go a bit crazy. We'll see. But if we run it, we should just see this essentially run, pause. This should be instantly filled. That's what we should see. And we won't see our red because it's probably going to be off somewhere in distant memory. Okay, so let's do that. I do want to let it do that. Yeah, you can do that. On track for an hour-ish, I think, which is not bad. Okay, fine. We don't need to do that. We can commit it. Okay, a few changes. Added the CPU now runs. Just push that up. Okay, so back to Claude. Can you add pause and run buttons to application? It's going to be here, isn't it? To /source/application/debug toolbar.tsx. Okay, so we have pause and run buttons. To the CPU. Okay, so it's wiring things up through the store. And yeah, again, just to belabor a point that I find the sort of the way to get the best out of these things is to write both the big specs and these little mini specs. You can, vibe your way through, and we did that a little bit yesterday. But for things that are more substantial, giving it a bit more of a grounding is really helpful, and having those sort of baseline specs in place are incredibly helpful. And I think that's an interesting thing. It's got some errors here which we have to look at. I think that's an interesting thing for future, perhaps, like people are writing specs in Jira. You need to give the LLM access to those, really. And I guess you could wire that through Jira. Jira might even have an MCP server now. You could just connect it directly to the LLM. I've not looked. I will have a look next week, and we could perhaps talk about that in a future episode, because I think the specifications are key, but they're not necessarily pure user specifications, so there's like an intermediate layer. But what I would really like to do, I guess if I was working on a user-facing feature, is be able to write, read this ticket, now read this implementation specification. And that's where I think we'll end up. But specifications, I think, are key in this world. Okay, so we've got a compile error here. Let's look at state, devkit state. Let's get in here. Looks okay, so it's console running. Oh, it's just WebStorm hasn't caught up. Wonderful, thanks for that, WebStorm. Okay, thanks for that, WebStorm. Really confusing. Let's just make sure let's just clear that down and run our browser. Okay. We want that disabled really when it's it's not loaded. Okay, so hang on, yeah, steps right, because it's not running. If we run it, pause it, there we go. It's run the CPU. The CPU is running. That's how many cycles it's gone through. Quite a lot, quite quickly. Probably about right, given the speed of my click. 3 megahertz. I was probably about just under a second in clicking it, so I think it's about right. Yes. Great. I think that's pretty cool. Again, just to reflect. At the end of this episode, in an hour. Is it an hour? Probably just over an hour. In an hour, 7 minutes, we have gone from, we've talked through some refactors, and then we've basically added assembly syntax highlighting to our system, to our custom assembly. So this is not off-the-shelf, assembly, but there's a big manual for somewhere. This is our custom CPU. So we've added syntax highlighting for the assembly language for our custom CPU, and then we've been able to get our CPU up and running in a web worker and configured with the debug tools. I think that's pretty good going inside an hour. And we've skimmed through some of the code, it's fine. I'll do another review probably after this episode, and maybe after the next episode, because there's a fair chance I'm going to roll through today and do 2. But I'll do the reviews kind of out of hours, as it were. You don't need to see me sift through line after line of code. But I think that hopefully that is interesting to people. Hopefully I've conveyed some interesting information on LLMs and on web stuff. I mean, the stuff about web workers, if you've not used those before, they are really helpful. We talked a little bit about how to get information backwards and forwards between them. Hopefully that's helpful to people who want to try kind of multi-threading in the browser. Great. Thanks for sticking with me. And in the next episode, it should be really exciting, because we're going to actually try and render some output to the screen. He says very nervously indeed. And there will be a bit more foreshadowing in the next episode too, I think. So if you're following the series, you can probably get a sense as to where it's going. Great. See you all next time.